Hello, we are going to look at example 31, and it says the heights of grade 6 boys at a large school follow normal distribution with mean 151.6 centimeters and standard deviation 7.9. If a boy in this group is selected at random, what is the probability that he has height less than 152 centimeters? And then we're going to find out it's between 150 and 157 centimeters. So the way that we would assign this, it tells us it's a normal distribution. So we know we should give a statement determining that we know this is a normal distribution, and we know that our mean is 151.6, and then our variance is going to be 7.9 squared. Good? And then the first one asks us is the probability that our random variable x is less than 152 centimeters, right? So that's what I want to find out. And like before, for normal distributions, we're always going to use the calculator. So I'm going to go menu, probability distributions, and I'm going to need CDF. And it's less than 150. I already got a very small negative number in there. It's going to go up to 152. And for this, I have my mean is 151.6, and my standard deviation is 7.9. And that would give me an answer here. So it's 0.52019. I guess I can round that up to just 0 to 3 significant digits that way. Now the next one is between, so this one's A, B is between 150 and 157. Pretty much use the same thing I have up here. My lower bound is going to be 150, and then my upper bound is 157. Is that right? Yeah, that's right. And I have the same, mean and standard deviation here, there, and that's going to come out to 0.333 to 3 significant figures. Yep, so that's good. And there you go. Now, next concept that we're going to talk about is we're going to look at this guy right here. So, example 32. And it says that given that x follows a normal distribution, that's the notation where we have mean of 1 and a variance of 3 squared but a standard deviation of 3, find the values a and b such that the probability that x is less than a is equal to 0.506, and the probability that x is greater than b is 0.198. Now notice if if we draw out a normal distribution, I just want to, any normal distribution, let's say this is a standard normal, right? This would be our PDF, right? That's our probability density function. But if we were to graph out its CDF, right, we'd be adding up all those probabilities. So CDFs kind of look something like this, right? That's what that looks like, right? And this is 1 to 1, right? And since this is our F, right, this would be our big F, right? Good. And it's 1 to 1. And we would have, so this does, for a cumulative distribution, this does have a inverse. There is an F inverse that exists. Now that's not so much for this. So, and the good thing is though, to be able to figure out this inverse, and we can use the calculator for it. So the first one says the probability that x is less than a is equal to 0.506. Let's get an idea what this looks like with the graph, right? We have a mean at 1 and a standard deviation of 3, right? So at 1, there's some maximum point. It looks something like this, right? So this is actually just a little bit past 0.5 of the graph. So somewhere, if this is 1, it's somewhere over here. This is where A is, so we can kind of get an idea of it, right? So, but my A is actually going to be the F inverse of whatever 0.506 is, right? Good, and then I can just calculate it using a calculator. So I'm going to go on, and I can go menu, statistics, distributions 5, and if you look down to 3, there's an inverse normal, and then I can put in my 0.506. This does have a mean of 1, a standard deviation of 3, and I get A to come out to be 1.045, and there you go. So that's what that one is. Now, what we have to be careful of is for this next one here. This guy here gives us our A, which is just a little bit past here. This gives us all, that's where all that area is just a little bit past half of it, right? So, but the next one, look what's happening. It's the same, we're using the same one, but it's asking for B is 0.19 of the graph, right? If I were to I'll draw it differently on this one, whereas that's like just a little bit under 20%, right? 20% of the area. If this is 1, and this is our standard deviation, right? 20%, I guess it kind of looks like somewhere right about here. This is where B is kind of by the symmetry of the graph, right? So I have to be careful. And unfortunately, this inverse will only give values less than, right? So I'd have to get greater than, for me to find, I know that the probability of x is greater than b is equal to 0.198, right? The inverse will not give me, in the calculator, will not give me this area right here. It would tell me, it would, basically if I get it, I get what's over here, this value, and it would be the totally wrong value. But I know that if this area right here is 0.198, I know everything this way is going to be 1 minus that, because all the area should all add up. Our CDF should add up, and that's what this big F stands for, the cumulative distribution. It's just it's the inverse of it, right? So I'm going to have to figure out what that is. 1 minus 0.198, right? Good. And now I'm going to have probability that x is greater than, or less than or equal, I should say, than b is going to be 0.802. Sorry, running off the graph right here. Now I can use the calculator to figure out what that is, right? Now my b is going to be the F inverse, the CDF of 0.802. And then I'll go inverse normal. I pretty much have it right up here. Now I can do it. And I can go 0.802. And now I can get my b is equal to 3.546, right? The good thing about normal distributions, we know by symmetry what it should kind of look like. And does that seem just about right? And yeah, it does. It does seem just about right. I mean, it's not for sure, but you know, sometimes when you make mistakes, they could be really off. So pay attention to the symmetry of the graph and make sure your answers are correct. Sound good, guys? Thanks.